Cramer's rule. So whenever we have an n by n linear system Ax is equal to b, where the n by n matrix A has a non-zero determinant, so determinant of A is non-zero here, then the system has a unique solution, and we can find this unique solution by using Cramer's rule. So the solution will be of the form x1 xn, and we can find each xi by just dividing the determinant of bi by determinant of A. So what is bi? Bi is the matrix obtained from A by replacing the ith column of A by the column vector B. So we have Ax is equal to B. Okay, let me give an example so you will understand better. Okay, let's solve this example using the Cramer's rule. Okay, let's write this system first as Ax is equal to B in the matrix form. So how we will do that? So we have 8, 5, and 2 minus 4 times x. So x1 is equal to x2 is equal to b, or minus 10. So the matrix A is equal to a 2 by 2 matrix. And okay, so we can use Cramer's rule if the determinant of A is non-zero. Okay, let's compute determinant of A. So we know that it is a 2 by 2 matrix. So how we compute the determinant? So we multiply these ones and we add, and we multiply this diagonal and we subtract. So it is 8 times minus 4 minus 5 times 2. Okay, what is it? It is minus 32 minus 10. So it is minus 42. So determinant of A is non-zero. So since determinant of A is non-zero, we can use Cramer's rule. So otherwise we cannot use Cramer's rule because we will not have a unique solution. If the determinant of A is 0, we will have infinitely many solutions. Okay, then so how we will find x1? x1 is equal to determinant of b1 over determinant of A. So this was the formula. And what is b1? It says b1 is the matrix obtained from A by replacing the, so we are looking b1, first column of A by the column vector of B. So b1 is, we will replace first column of A by B. Okay, whenever we see A, we will write A, but in the first column we will write B. Great, so in the first column we will write B. Okay, what is determinant of B1 in this case? It is 2 times minus 4. Okay, sorry, I cannot write here. What is determinant of B1? So it is 2 times minus 4 minus 5 times minus 10. So recall B plus B, subtract this diagonal. So it is minus 8 plus 50. So it is again 42, right? 42. But determinant of A was minus 42. So x1 is then what is x1? Determinant of b1 is 42. Determinant of A is 42. So it is x1 is equal to 1. What about x2? So we have determinant of b2 over determinant of A. What is b2? We write A, and in the second column we write B. So it is 10, 2 minus 10. What is the determinant of B2? minus 4. So it is minus 8, 4. So x2 is equal to minus 8, 4 over minus 42. So it is equal to 2, right? So what is the solution? Therefore, the solution set is s is equal to, so we have a unique solution, x1, x2, which is equal to x1, 1, x2 is equal to 2, sorry, x1 is minus 1, minus 1, 2. Great, okay, let's do another example. Now we will solve the following system by using Cramer's rule. Okay, but first let's write the system. A times x is equal to b. Okay, we can write it like this: 1 minus 1, 1, 1, 1 minus 1, 2 minus 1. Oh, sorry. Yes, I am going to solve this one. So x1, x2, x3, and which is equal to 4 minus 2, 1. Okay, let's compute the determinant of a first. So 1 minus 1, 1, 1, 1 minus 1, 2 minus 1, minus 1. So this is a 3 by 3 matrix. How we compute the determinant? 1 times. So we close first row, first column. So we have 1 minus 1, minus 1, minus 1. Minus 1 is 1 times 1 minus 1, 2 minus 1, plus 1 times. So if you remember, we will we will remove first row and the last column. So we will get 2, 1. Sorry, 1, 1, 2 minus 1. And then these are 2 by 2 matrix. So we know how to complete the determinant. So it is 1 times minus 1, minus 1 is plus, minus 1 plus 1, minus 1 plus 2, minus 2. Okay, what is this? It is minus 2. What is it? Plus 1, minus 3. So what is the determinant? It is minus 4. So determinant of a is equal to minus 4, and it is now 0. Then we can use Cramer's rule, and we know there is a unique solution. Okay, so what is x1 is, we know determinant b1 over determinant of a, and b1 in this case. So we will write a, but we will replace first column by b. Okay, 4 minus 2, 1, and the rest is the same as a. Let me compute the determinant of b1, but I will leave b2, determinant of b2 and b3 to you. So this is 4 times 1 minus 1 minus 1 minus 1 minus 1 1 minus 1 plus 1 minus 2 minus 1 1 minus 1. Okay, what is this? It is minus 1, minus 1, 2, minus 1, it is plus 1, plus 1, 2 minus, okay, you know how to compute, how we compute, minus 1, it is plus 1. So minus 2 times 4, it is minus 8, plus 3, so we should find minus 2, but I think I'm making a mistake because I should find minus 4 here. Okay, where did I do wrong? So I think I did wrong something here. Minus 2, minus 1. Okay, I did where I find. Okay, here I made a mistake here. What is this? This is plus 1 times. Okay, we close this row, this column, so it is minus 2, 1, 1 minus 1. Minus 2, 1, 1 minus 1. Then what is it? 2, 2 minus 1. So we should have 2 minus 1. It is plus 1. So we should have minus 4 here. Great, so now it is correct. And we find determinant of B1 over determinant of A, minus 4 over minus 4, x1 is 1. What about x2? x2 is determinant of B2 over determinant of A. What is B2? So we will write A, but for B2 we will replace the second column with B. Okay, I cannot see A here. Okay, let me copy here. So this was A. So we will replace 1, 1, 2. Second column with B, 4 minus 2, 1. 4 minus 2, 1. 1 minus 1 minus 1. But okay, check. Determinant B2 is equal to, what is the determinant of B2? I think it is 4. Then x2 is equal to 4 over minus 4. So it should be minus 1. What about x3? Determinant of B3 over determinant of A. So we know determinant of A is minus 4. So what is B3? B3, we replace the third column with the B. 1 minus 1, okay, let me write 1 minus 1, 4. 1 minus 1, 1, 1, 2 minus 1. 1, 1, 2 minus 1. What is B? 4 minus 2, 1. And if you compute the determinant of B2, you should find minus 8. So then x3 is equal to 3. So the unique solution is x1, x2, x3 such that x1 is 1 minus 1, 2.